Lester, Wushu engineer. In some of my past videos, I've mentioned the collaborative scientific research that the Wushu Scientist and I are engaged in with the University of Southern Queensland here in Australia. I encourage you to check those videos out for a more detailed context regarding the Wushu Scientist's Master's Research Project and her current PhD research project. To sum up our research efforts in a nutshell, we are actively engaged in experimental research into the internal aspects of traditional Kung Fu, in particular the concept of Qi and how it relates to the generation and control of intra-abdominal pressure. The Wushu Scientist's current PhD research project involves a significant intervention study, as well as a number of smaller studies and development projects. The intervention study involves the development and testing of a training program, incorporating traditional internal training aspects such as Qigong breathing and Qigong breath control, specific isometric and plyometric exercises, specialized electronic biofeedback techniques and equipment, and modernized scientific training instruction to teach elementary internal control to a test group made up of military and emergency services personnel. Qigong training is a traditional form of internal training involving awareness, intention, meditation, breathing, and breath control. It's often taught as a standalone system, but is also incorporated into martial arts practice. All of the physical movements and attacks and defenses that form part of our traditional forms and techniques, for instance, are accompanied by their own internal specific Qigong techniques. Qigong can be broadly divided into health-based Qigong, which was developed primarily to improve health, and martial Qigong, which was developed to improve martial performance. However, health-based and martial Qigong share many characteristics, and there is a strong overlap. The challenge that I face as part of this study is to teach the test group in a very limited period of time, 3 months. Typically, decades are required to teach internal control using traditional training methods. Additionally, the failure rate is possibly higher than 90%. That means that of all the students who persist in their traditional training methods, so I'm not talking about students who come and train for only a few years and leave, those who persist, only a very small percentage will actually be able to use internal control techniques to achieve any measurable results. So I'm understandably a bit nervous about whether I can accomplish this, hence the incorporation of a more understandable scientific framework for the training instruction and the use of new and advanced biofeedback techniques to give the best possible chances of success with our participants. I'll have some footage from a traditional Purple Cloud Qigong training session playing in the background for those of you who have not seen a Qigong class before. The Purple Cloud Qigong system is what we class as a health-based Qigong system. As a matter of interest, during this particular Purple Cloud Qigong session, I monitored my blood oxygen level and heart rate, hence the sensor on one of my fingers and the periodic breaks I took to record values. My personal resting heart rate is approximately 45 beats per minute. And it turned out that my heart rate varied between 60 and 83 beats per minute during the Qigong session. So there was significant increase in my heart rate during the session. My blood oxygen level varied between 89 and 99 through the session. So as part of the intervention section of the Wushu Scientist's study, we will be testing changes to the test group's ability to generate isometric forces under various conditions. We'll be assessing their striking potential using the impulse block method and equipment, and the group's ability to unload or protect the spine during heavy load carriage. One of the most important questions addressed in the study is whether we can use the training program to teach the test group to unload the spine and thus prevent spinal injury during heavy load carriage. I'm going to provide a little bit more background to the study now, and while I'm providing that background, I'll be flashing up some of my references on the screen while I'm talking. Worldwide, there are more than 27 million employed military personnel and 15 million employed firefighters. Individuals in the military and emergency services are often required to carry heavy equipment and supplies on their body during training and operations. The weight of these loads has steadily increased over the years due to the introduction of new technologies to increase firepower, protection, and communications. The average load carried by soldiers engaged in international conflicts is now close to 50 kilograms, and modern firefighters wear approximately 20 kilograms of protective equipment. A heavy load is commonly defined as a load that is over 30% of an individual's body weight. Load carriage tasks require increased strength and endurance and place increased strain on the muscles and skeletal structures that can lead to injuries and reduced performance. Based on a review of 1,954 injury records from an Australian Defence Force database, the back was found to be the leading site of load carriage related injuries. It has also been reported that both anterior and posterior load carriage resulted in large increases to spinal compression. Additionally, continuous spinal compression has been found to increase the risk of disc degeneration. This is a major concern to military and emergency services organizations, primarily because injuries and reduced performance may compromise operations and lead to absences from duties. But of course, there's the human cost involved as well, which shouldn't be ignored. Accordingly, there is an urgent need for strategies to overcome the problems caused by heavy load carriage. Previous research has investigated potential solutions to the problem caused by heavy load carriage. These solutions have included technical developments to reduce the weight of equipment, the use of a soldier load planning model, development of specialized load carrying equipment, and physical training programs to condition soldiers for load carriage. However, specialized load carrying equipment and other technology designed to assist with load carriage, such as robotic exoskeletons, are generally very costly, difficult to implement successfully. A simple, cost-effective approach to address the problems caused by heavy load carriage may be to train individuals to increase the pressures created within the abdomen. A number of studies have investigated the effect of increased intra-abdominal pressure on spinal unloading using models, which have shown that increased intra-abdominal pressure causes spinal unloading. So it is proposed as part of the Wushu Scientist's study that increased intra-abdominal pressure during load carriage may assist with heavy load carriage performance by unloading the spine. In the Wushu Scientist's previous study, it was found that trained martial arts practitioners could in fact generate higher intra-abdominal pressures in relation to thoracic pressures and were able to increase their intra-abdominal pressures and produce greater forces than untrained controls during isometric force production and resistance exercises. However, no research has yet investigated the effects on heavy load carriage performance of training individuals to increase intra-abdominal pressures or have directly measured the effect of this training on spinal compression. Therefore, this research project will investigate whether acute and chronic martial arts-based breath control training can improve strength and load carriage performance. This would provide a simple and cost-effective approach to overcome the problems caused by heavy load carriage. Of course, my ability to develop and teach this new training program to military and emergency services personnel is critically dependent on whether or not I can actually use internal control to unload my spine. I do not believe that you can effectively teach something that you cannot do yourself. So we needed to confirm whether what I felt in my own body during training was actually happening in real life. We needed to confirm whether I was able to create and direct internal pressures to lengthen and up and unload my spine. To that end, the Wushu Scientist and I did some preliminary investigations into my ability to lengthen and unload my spine using only Qigong breathing and internal pressure control techniques. We used an ultrasound machine to monitor and record my spine during a set of exercises in which I tried to extend my spine and increase the width of my intervertebral spaces, or the distance between individual vertebrae. It must be stated here that this was merely a preliminary investigation, and that there are a number of factors that need to be confirmed before the results can be properly considered. One of the outstanding items yet to be performed is reliability testing of the ultrasound method. Another is the development of a stable harness to keep the ultrasound sensor stationary and in place on the participant's back during the measurements. However, I was quite excited about the results, and I felt that they were interesting enough to share on my channel despite the need for further validation and verification. This is what the tests looked like. So just to give you a brief rundown of what we're doing here, this bench is purely here so that I can actually lean up against it slightly so that I don't have to resist Sherilyn pushing me and make it a little bit more complex for me to concentrate on the extension and the contraction of my spine using internal pressure. So that's all that this is here for. I might just put my hands like so, just to give me a bit of additional stability, or I might just lean up against it slightly. The equipment here, we've got the ultrasound machine over here, which the Wushu Scientist is going to be using to have a look at my my vertebra and my intravertebral spaces, and got the output from the machine going onto the laptop there, which is being recorded so that we can do measurements on that afterwards. So there are two different scenarios that we're going to be looking at. First of all, just without any additional load on me, I'm going to be using Qigong to lengthen and to extend and collapse the spine, just extend it and contract it. And then I'm going to do it without a modulated. So the first exercise will be a very controlled modulated breath. So I'm going to time it with the breath. Then I'm going to try and do it internally while keeping my breathing pattern normal. So I'm just going to try and maintain that. And then I'm going to move on to these two concrete blocks over here. These are about 28 kilograms each. I'm going to lift those, and I'm going to try and do similar exercises there, extending and contracting the spine while holding those weights. So a total of just under 60 kilograms.
Okay, so we're going to start with, first of all, just finding spinal vertebra. Okay, and then right there we can see we've got a couple of, those are the transverse processes of the vertebra. And I'm just going to move up just to find the last rib. Get some more gel. Okay, that's better. Nothing.
Get that?
And again. And and one more. Okay.
Are you seeing anything?
I think there's little bits of movement. We're going to have to just analyze that on the computer and go from there. So the next.
So now I'm going to extend the spine, and I'm just going to do that internally. So I'm going to use it with internal pressure control and continue breathing normally for a period of time.
Okay.
Maybe just a few seconds. Now I'm going to relax. Okay.
Good.
See anything?
Pretty sure.
Okay. So let's go on to the weights.
Okay. This is going to be interesting.
So I'm just going to lift them, and then I'm going to sort of I'm not going to try and engage internally to extend the spine. I'm just going to try and hold them without actually engaging any kind of internal pressure. And then I'm going to try and engage internal pressure and then extend through the spine while holding the weights. Okay. So I'm going to, so are you ready?
Yeah.
Just tell me when to go.
Yeah. I'll just say so.
Okay.
Extending?
Yeah. Now I'm going to relax. You see anything?
Possibly.
It might be quite small. I'll do it again. Are you ready?
Yeah. Okay, that was, sorry, that's not good enough. I have to just find one more. Okay.
Now I'm going to relax. Okay.
Okay. All right. Good. All right.
I chose to use two 28 kilogram weights for a total of 56 kilograms in the loaded test because this represents over 60% of my body weight. Based on the reference mentioned earlier in the video, this is twice what would be considered a heavy load for someone of my body weight. The results of the ultrasound recording seem to indicate that I was able to consciously extend my spine and increase the distance between my vertebrae under all test conditions. In some cases, I was consciously able to increase the intervertebral distance by more than 3.5 millimeters. What was most interesting was that the most significant results seemed to be associated with the set of tests during which I attempted to extend my spine while breathing at a normal pace and without linking the breath with the extension. Another interesting result was that while holding the 56 kilogram load, the distance between my vertebrae appeared to be the same as when I was unloaded. This seemed to indicate that my intervertebral spaces did not show any sign of being compressed under that load, and that I was naturally using my control of internal pressure to protect my spine while I was holding the weight. I was also able to extend my spine under the load, but the extent of the expansion appeared to be diminished compared to my performance during the unloaded tests. These results are really interesting, and they provide a good basis and foundation, giving us a little bit more confidence in what we are attempting to do as part of this PhD study that the Wushu Scientist is engaged in. It's our hope that the results of this research and the training programs and teaching methods developed as part of the project can be used to improve the quality of life of many people by giving them the ability to protect their spines from damage associated with spinal compression during load carriage. I hope you enjoyed this video, and I'll see you all again next time. Cheers!